Number 10 asks me to identify the open intervals where f of x is increasing and decreasing. To find where graph's increasing and decreasing, I need to take the derivative and set the derivative equal to 0. I can then create a number line where positives mean increasing and negatives mean decreasing. So first step is f prime of x. X squared becomes 2x, negative 2x becomes minus 2, and the negative 80 drops off. Here, when I go to factor, I can take a 2 out, and it becomes 2 times x minus 1. There's no way to make 2 zeros, so there's no critical number found there, but x minus 1 becomes 0 if I put in a 1 for x. That tells me that the number line we're dealing with has one value, 1 that I care about, and I want to see to the left of 1, to the right of 1, do I get positive or negative answers. So I'm going to start out with something to the left of 1, specifically 0. 2 times 0 minus 1 would be 2 times negative 1 or negative 2. That tells me this whole region is going to give me negative answers. When I plug into the derivative something to the right of 1, let's say 2, I get 2 times 2 minus 1, or 2 times 1, which gives me positive 2, which tells me this whole region is positive. Once I have each of the regions filled in with their signs, the critical values listed, I now just have to translate that into increasing and decreasing. Increasing is wherever I see a positive sign, so that starts at the x value of 1, and it goes up till infinity. Where I see the negative sign starts at negative infinity and stops at 1. For number 11, we're doing the same general thing, except we're taking a second derivative here because we're looking for concavity, not increasing, decreasing. So I start out by finding g prime of x. 2 comes down, it becomes 48x. 3 comes down, it becomes minus 3x squared. When I take the second derivative, g double prime of x, 48 minus 2 times 3 gives me 6x. If I factor a 6 out here, I get 6 times 8 minus x, which tells me that 8 is the critical value. In this case, we really call it a point of inflection. So I'm going to make my number line with that point of inflection at x equals positive 8. I'm going to plug something into the number line before positive 8. So let's try 0. If I put 0 in for x, 6 times 8 gives me 48, which is positive. So this whole section is positive. If I plug in something bigger than 8, let's say 10, 8 minus 10 is negative 2, times 6 is negative 12, telling me this whole section is negative. And now I need to translate this in the same way that I did above, except saying that positive means concave up and negative means concave down. So concave up starts all the way as far as I can think this way, negative infinity, and goes up to the number 8. Concave down starts at 8 and goes up to infinity. If it asks me what the point of inflection was, the point of inflection is x equals 8, and then I plug 8 back into here to solve out and find what the y value is that goes along with it. Number 12 asks me to find each limit if it exists. I will say that C is a little tricky here, so pay attention when I get to it. But basically, I just need to think which is bigger, the highest power of x on top or the highest power of x on bottom. When I look at the first one, the highest power of x on top is this negative 6x. Highest power of x on bottom is this 5x to the third. The bottom is clearly a higher power of x. For that reason, the limit is 0 as x approaches infinity. When I look at part B, I would highlight this negative 6x and this positive 5x. This is a time when we have the same power of x on top and bottom. When that occurs, the limit is a ratio of the coefficients. Or in other words, it's like I ignore everything else in the problem except for these two. It becomes negative 6x over 5x, and these x's go away to give me negative 6 over 5. I think you're probably better off putting it in as a fraction like that, but if you want it as a decimal, it should also accept negative 1.2 as the limit. For C, normally when you have the higher power of x on top, I've said it means that the limit does not exist or goes to infinity. Here, because the negative is associated with that higher power of x, they want the answer to be negative infinity. So make sure when you take the actual final, if it's a question like this, where the larger power of x is on top but it's negative, the answer is not infinity, but negative infinity.